The compute bottleneck for large language models is being shattered, not by software, but by a radical shift in physics. A new study in Nature Computational Science presents an analog in-memory computing attention mechanism that delivers monumental efficiency gains. How it works. Current GPUs waste enormous energy shuffling data between processor and memory. Von Neumann bottleneck. This new architecture uses gain cell devices to perform calculations directly within memory using analog signals. This eliminates data transfer latency and power loss, a fundamental departure from traditional digital systems. The impact. The result is a potential 100x speed boost and an unprecedented 10,000x gain in energy efficiency over GPUs. This is the path to scaling state-of-the-art LLMs, demonstrated at GPT-2 level performance for deployment on edge devices, phones, and IoT hardware, offline and locally. The future of AI is moving beyond the cloud and into the chip's core. Success in this decentralized era requires a partner who understands and can build the full compute stack, from novel physics to optimized inference software.